Welcome to Brain Vision.
16.8. So we have a plot of the transverse velocity versus time at the x equals 0 on a string. That obviously has a wave going on it. The scale of this is set by 4 meters per second. Now this is the generic form that the wave has, and so we want to figure out what this phase phi is. And it warns us about potential issues with inverse trig functions on calculators. So we're going to have to be a little bit careful of that. Now we're told this is at x equals 0. So we know that the speed is just going to be the time derivative of this. So we're going to get a negative omega from the chain rule. Then our y sub m is still there. And we'll have a cosine of negative omega t plus phi. So this is our function that's being plotted here. So at t equals 0, the slope of this is positive. This is at time 0, so we just have the phase here. So this is going to help us get the correct angle here, noting that this has to be positive. More specifically, negative sine of phi is positive because y sub m and omega squared are positive, and we could divide both sides of this by those, and so we just get negative sine of phi is greater than 0. So this means that phi is either in the third or fourth quadrant. So now at time 0, u is negative 4 meters per second. Just from the plot here. And u max is 5 meters per second. Because note that the scale extends up to 5. So the thing that gives us the scale, what the scale of the axis is at 4, but then we have an additional sort of tick mark up to 5, and that's the maximum value it takes. And this also has to be equal to omega times y sub m. So we have u equals negative u max times the cosine of negative omega t plus phi. We want this at t equals 0. So this is going to be 4, and this is going to be 5. This is going to be 0. So we have that the phase is going to be an arc cosine of 4/5. And so this is going to be either plus or minus 0.643 5 radians. We're using the fact that cosine is an even function, so we can multiply this by -1 and it doesn't affect the we can multiply the argument to it by -1 and it doesn't affect the sign of the result. Now, because we said that the angle has to be in the third or the fourth quadrant, we need the -1 because we measure angles from the positive x-axis, of course. And so we have like 2 possible angles here, and it has to be this one because it has to be in either the third or the fourth quadrant, and so a negative, angle that's less than pi radians will be in the third or fourth quadrants. So we end up with the phase is -0.06435 radians. And of course, we could also add any integer multiple of 2 pi to this, or subtract any integer multiple of 2 pi, and it would be the same angle. But so if you wanted to express this as being positive, you can add 2 pi to it and get 5.64 radians. So that it's, instead of starting at the x-axis and going back a bit, you start at the x-axis and then go all the way around to where it is, and that's 5.64 radians. But these are the same angle.